What's up, good people? Thank you for joining. Thank you for liking this video. And if you're a new member, welcome to the family. Thank you for subscribing. My name is Percival Parati. So in this video we'll be learning about trigonometry. And we're going to go to details about trigonometry, but especially the trigonometric graph. So we'll be learning about tan, and we'll be learning about sun graphs, right? So just tune in. We learn a lot about tan and sun graph in this video, right? So we're using November 2022 past paper 2, question 2 for grade 12. Okay, so let's go. In the diagram below, the graphs of f of x, so you have graph of f of x, which is tan x, and the graph of 2 sine 2x are drawn for the interval negative 180 to positive 180. So they're from this to their period. And this is A is an intercept, and B are 2 points of intercept of f and g. Okay, so I mean, first thing first, I think we need to start identifying this intercept, because the intercepts, they repeat themselves, right? It's nothing really new. The only difference is the quadrant, right? So as you can see, there's an intercept here at this point, and so this point here, this is k, this y value is k. So already we know the x value of b. We don't know it yet, I'll show you, but we know it. But the y value of b, we know it is k. Why? Because it's on the same horizontal line. And this also goes with this one as well here. This value here, it's still y, y is equal to negative k, right? Why? Because the wavelength, it move, this wavelength, if you look at it, and move from 2 to 2. So it move from 2 to negative, from negative 2 to 2. So this point here, it's negative 2, and this point here are positive 2. So they're the same point. So it move from negative 2 to 2. Move from negative 2 to 2. Move from negative 2 to 2. Okay, so it moved from, if you look at it, it moved from negative 2 to 2, go down negative 2 to 2, go down to negative 2 to 2. And then, so that's what you have. And from here, what you need to, what else do you need to understand? I need to also highlight something here, xb. xb and this point here as well, we don't know this point, but it's worth highlighting. This is on the first quadrile, this is on the fourth quadrile, right, going negative direction. So meaning this is negative 60 as well, and k is negative in this case, negative k. Why? Because this point here is opposite that point. So if a is 60 and k, that point there that we don't know is going to be negative 60 and negative k. Okay, it's very important to understand these things, because when they ask you a question, they're going to be based on this information here. And it's very important that before you jump into questions, to understand exactly what you're being given, because that is your gateway. That's how you're going to be winning. Okay, so we have discovered this point is negative 60 degrees and negative k. If that you don't understand, please let me know. And so if you think about it, actually, let's look at the quadratic equations. So this is 0 degrees. This is negative 90 degrees if you're going clockwise direction. If you're going anti-clockwise, this is positive 90 degrees. Right, so if continue going anti-clockwise, this is 180 degrees. But if you are going this direction, clockwise direction, this is going to be negative 180 degrees. So we are going this way, and we are going that way. We're going anti-clockwise and clockwise direction. That's what we are doing here. We're going anti-clockwise and clockwise direction. Okay, so what we've discovered, that we have a point here that is here at A, and that point is 60 degrees and K. And we have a mirror point here, and that point is negative A, which is negative 60 and negative K, and negative 60 and negative K. Right. And then we have now another point B there, and point B is on the third quadrant, on the when you move in clockwise direction. So we have another point here. As you can see, this point is on the third quadrant, so it's between negative 90 and negative 80. So meaning that point is point B. So meaning this negative 60 is no longer just negative 60, but it's between negative 80 and negative 90. So it's 180 degrees minus 60 degrees. Alright, this is 180 degrees minus 60 degrees. It's 180 degrees minus 60 degrees. Oh, alright. It's better to say it's 90 degrees plus 60 degrees. Or you can say it's not 180 minus, it's negative 60 degrees plus 180 degrees. Boom. So point B is essentially on this point here, right? This is a direct opposite that point. So the direct opposite of that point, we still have K as negative, but point B, we cannot really say it's negative because this is negative 60. But we have this point here, somewhere here, between 90 degrees and 180. And that point between 90 degrees and 180, it is negative. So it's going to be negative, it's going to be 60 minus 180. That's the point. 60 degrees minus 180. 6 degrees minus 180. And that's the point. So it's going to be, so B is going to be 60 degrees minus 180, which is minus 120 degrees and K. And it's very important to understand that. So XB in this case is negative 120 degrees and K. It's the same as positive 60 on the first quadrant, but it's negative 120 on the third quadrant. And it's very important to understand that. Yeah, so that's the information that you've been given, and that's what you're going to be harnessing. We're going to be harnessing this information that you've been given, and you're going to use it in our advantage. Right, so first thing first, write down the period of G. All right, so period of G, let me just bring a different color. Period of G. So with period, just give quick revision on period. So if this is sine X, a period is the distance where this function would fully give your shape, right? So if it's sine X, the period, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees. So the period of this, the period of this is 360 degrees. For it to fully show you the full shape of S, because the sine wave is this S, it's going to give you 360 degrees. Now, if you have sine 1 over 3, alright, let me put it this way. If you have sine 3x, right, the period of sine 3x is 360 degrees divided by 3. So you're dividing the whole thing by 3. So that's going to be the period. So it becomes smaller. So the period will be 360 degrees divided by 3, and the period is, can punch that in calculator if you want to, but it's going to be 120 degrees. Now, if you have sine of 1 over 3x, so what is the period? So with this case, now if it's division, it's going to be multiplication, so it's going to be 3 times 360 degrees. So 3 times 360 degrees is 1080 degrees. So the period of 1 over 3x is that. So that's how you calculate the period. So with tan x, I'm giving you context as well. I mean, okay, let me just go with cos. Cos x, same thing, right? I don't have to draw the graph for you, but same thing. If you have cos of 3x, or rather, start here. Cos of x, the period, let's call it P for now, is 360 degrees. But the cos of 1 over 3x, so the period is 3 times 360 degrees. So now if it's cos 3x, the period is 360 degrees divided by 3. Right? Now if it's tan x, the period of tan x is 180 degrees. So if it's tan 1 over 3x, the period is 180 degrees times 3. Tan 3x, the period is 180 degrees divided by 3. Make sense? So that's how you will calculate the period of sine, tan, and cos. So period meaning how long does it take to fully show the shape of that wave. So if you're talking about sine, the shape is this. If you talk about cos, this is the shape. If you talk about tan, this is the shape. How long does it take to fully show that shape? That's basically what the period is. You don't have to even see in the picture, you can just calculate it this way. You're always going to get it right if you calculate it. Alright, so now let's go back to the question. Write down the period of G. If you go to G, that's G. G is 2 sine 2x, so the period is 360 degrees divided by, I need to use a different color, I guess. Or maybe let's keep it this way. 360 degrees divided by 2. That's the period. And that is 180 degrees. The period is 180 degrees. And then, if you don't understand this, please let me know. I'm happy to revise this one with you. So 6.2.1, calculate the value of K. K, where's K? So yes, see now, it's going where we wanted, where we suspected it's gonna go, right? We've already studied K, we've already studied the intercept already. So we are ready for this. Calculate the value of K. The value of K, if you look at this, this is A, and it takes F, right? So if you take F and 60 and substitute where the value of X is 60, you're going to get K. So what I'm saying is, K is equal to F of 60, right? Where X is 60, you're going to get K. Whether you use F or G is the same thing. You know, K is equal to G of 60 as well. Same thing. So let's take F. So take G if you want to and tell me if you get the same answer, okay? If you don't, let me know. I'll show you how to do it. It's different, but the answer will be the same. So tan of 60 degrees. So how do you get tan of 60 degrees? You can punch this in your calculator. That's very important. If you punch it in your calculator, you're going to go square root of 3. Easy. That's your mark. Square root of 3. Punch this in your calculator to get square root of 3. Yeah. I don't want you to... Oh, probably I'm tempted to actually. I'm tempted to tell you how you would do it without a calculator. I was like, nah, I don't want to, but I'm like, nah, I do want to. I do want you to know. This is square root of 3. This is 2. That's what you'll use, and we know that tan is opposite over adjacent, and we're looking at 60. So the opposite side is square root of 3, and the adjacent side is 1. So it's going to be square root of 3 over 1, and square root of 3 is just square root of 3 over 1 is just square root of 3. That's how we use it. Do it without a calculator. Okay, so calculate the coordinate of B. Ooh, C. So we already know that B, we already know that B is equal to what? B is equal to yeah. B is equal to okay, we don't know yet the x value of B, but you know now the y value of B. The y value of B is K, and that K is, we just calculated now, square root of 3. But we just calculated that this x value of B is negative 120. Why is negative 120? Because, because it's the same value as negative, it's the same value as 60 degrees, but on the third quadrile moving clockwise direction. So it's going to be negative 60 degrees. That's not negative 60 degrees, rather. It's going to be positive 60 degrees. So it's going to be 60 degrees minus 180 and square root of 3, which is negative 120 degrees square root of 3, and that's your answer. Square root of negative 120 gives square root of 3, and it's 1 mark. These are the things that you just could you see it, and you only see them when you start studying what you're given first before you jump to question. Start what you're given first, and then boom, you jump to the question. Okay, 6.3. Write down the range of two to this. Okay, cool. So first thing first, you need to understand the range. What is the range? The range is the distance. I mean, if you have a I need to use it. If you have a cos x, okay, and what is the range of this? The range of this is, it's from a to a. Even if you have a sine x, the range of this is from a to a. That's the range. That looks like 9. From a to a, that's the range, right? So you have f of x. This is, that's the range. So now in this case, you have we're looking at g. So g is equal to 2 sine 2x. So that's g. So if you're looking at g alone, g you need g 2 sine 2x. Is it 2x? Yeah, go. Okay, so g 2 sine 2x. So what is the range of g? The range of g is negative 2 to 2. Now you have 2 g of x, which is 4, right? 2 of x is actually 2 times 2 sine 2x, which is 4 sine 2x. So the range of 2g of x is 4 sine 2x. So the range is negative 4 to positive 4. And you get your marks. Okay. If you don't understand this, let me know. I'm happy to revise it with you, but that's your range. Okay. And then 6.4. For which values of x will I love these questions. Would g of x plus 5 minus f of x plus 5 less than 0 in an interval? In an interval negative 90 and 0. So you're looking at this interval here, negative 90 and 0. So if you look at this interval, you're only looking at this picture, right? And they say, for which values of x would g of x would g of x less than, okay. So see this. This is what I want you to see. So if you have, when they say g of x is less than, g of x minus, I want to say less than, but I want to bring the picture with you. Okay, let me just calm down because I'm getting excited a little bit. Okay, I want to read this with you, right? So you have g of x plus 5 degrees minus f of x plus 5 degrees less than 0. Okay, so this means, think about this before we move too quick. Let me bring this color here. This means, number one, it means two things. If you're looking at just g and f without really what is inside, this means that g is less than 0. G is less than f. That's what it means, where g is less than f. So meaning f is greater than g. If you go back, f is greater than g, where if you're looking at here, from this point from 180 to negative 90, or you see that f, this is g, you see that g is greater than f. So that doesn't qualify. But if it goes, but when you come here, g is less than f. This is where g is less than f. And then here, g is greater than f. It goes, and then g is less than f here. So this is the point where g is less than f. G is less than f at this point. G is less than f at this point. G is less than f at this point. This is the only point where g is less than f. Okay, that's what this says. This says that, and then second thing it says you are shifting both g and f 5 units to the left. You're shifting both G and F 5 units to the left. Okay, so number one, we've discovered that F and G are both, F is greater than G at this point. So what is this point? This point is, this is negative 60. We've calculated that. This is a reason why we had to discover the intercept first, before you even answer the questions, because if you didn't discover the intercept first, this was going to confuse you. But we already discovered the intercept first, just looking at what we've been given. So now we know that G is less than F between negative 60 and 0. So that's we know. We know for the fact that this is true where, let me write a different color, where X is between negative 6 degrees and 0. Now, what they say, they moved out 5 degrees unit to the left. 5 degrees to the left. They've moved both G and F 5 degrees to the left. So what does that mean? It means that your X now is moved 5 degrees to the left. So you minus both sides. Degrees minus 5. It's moved 5 degrees to the left. So X is equal to, or X is an element of negative 65 degrees and negative 5 degrees. That's why I was excited, because these are really nice questions. And this can, how many marks is this? 2 marks. Stingy. Okay, cool. So you get a mark for this and that. Right, let me know if you don't understand this, but yeah, these are nice questions. Determine the value of P for which sine X cos X equal to P will have exactly 2 real roots in the interval X is in between negative 180 and 80. Okay, so damn, these are nice questions. These are really good questions. Oh my god, these are really good questions. Determine the values of P for which sine X cos X is equal to P would have exactly 2 real roots in interval. Okay, all right. So the way you need to think about this, all right, is, oh wow. So, wow, this is a really good question. So the way you need to think about this is this way. You have, what do you have? You have G of X is equal to 2 sine 2x. So 2 sine 2x is already, this is G of X. This is already in between negative 2 and 2. We already know that it is moving from negative 2 and 2. Already know that. That's what it moved. It moved from, it cannot move, between negative 2 and 2. Alright, this is positive 2, this is 2, and it moved between that. That is the range of G from negative 2 and 2. We've discussed that on previous on previous questions. So it moved between negative 2 and 2. Okay, that's what we know. So what does that mean? So it means that 2 sine 2x is equal to plus or minus 2. That's what that means. 2 sine 2x is equal to plus or minus 2. Those are the 2 exact roots of 2 sine 2x. Those are 2 exact roots, real roots of 2 sine 2x. Real root intervals. 2 sine 2x is equal to plus or minus 2. Okay. Now, let's go back to the question. Now, they want us to find P would have exactly 2 real roots intervals. Now, what is sine 2? So how do we then associate these two? So you see already that you have sine x cos x is equal to P. If you times it by 2 on both sides, you're going to have 2 sine x cos x equal to 2p. And we know that 2 sine x cos x is equal to sine 2x. So sine 2x is equal to 2p. Okay, if we times by 2 on both sides, again, this is 2 sine 2x is equal to 4p. Aha! So therefore, 4p is equal to plus or minus 2. Then you divide by 4 both sides. Therefore, P is equal to plus or minus 1 over 2. So P is equal to plus or minus 1 over 2. Let me know. Let me know if you really get this, but it's really exciting, and I'm happy we did this question together, and I hope you've learned a couple of things. If you do, smash that like button. It's gonna help me and motivate me to push more content like this, just to help you understand what exactly is happening and help you prepare for your exams. And yeah, so make sure you share this with your fellow students, your friends, and thank you for commenting. If you have a question, just don't be afraid. This is a safe space. I'll be reading your comment and I'm happy to answer your comment. So please make sure you ask your question, and if you have any suggestions or anything that you want to ask, say, feel free to write it down in your comments. And what else and yeah, if you're a new member, I hope you like this content. Subscribe. Don't forget the notification bell. I'll be really posting a lot of content till December, so hopefully a lot of you guys will be doing very well after then. Boom.